Assalamu alaikum.
Welcome, so I'm sorry, I had to print something out and my
No,
mom
no
just
problem. Okay. Did you enjoy the match? It was a water thrilling match.
it was all right. It was all right.
You did not enjoy it that much, I guess. Oh my gosh, I haven't seen such a thing in my whole life of watching cricket. Like everyone is
Oh, the
sitting
actual,
there.
the match. Oh, this is the math. Okay, yeah, no, I was actually there. And
Yes, yes.
yeah, it was actually so close. So
Wait,
close.
Bangladesh won the match for at first. Then the
It
umpire
was no
calls it a
ball.
no ball. Then everyone comes back and
Yeah.
put the stamps back again. Oh my gosh!
Yeah, it was
At that moment, I
crazy.
thought we're going to lose the match, but
Nah,
somehow,
I didn't doubt in 1 second, mostly. Only three
so
runs, so
yeah,
that's
you guys
crazy.
have got your money's worth while watching the match.
Yes. Yes, it was. Especially, oh, and I got a jersey signed by all of them as well.
Oh, that's great.
Yeah.
Okay,
So this one, this one.
so this is very good. I mean, whole family went there.
Just me and my mom, but
Okay,
my brother was there too.
all right.
Somehow, I don't know how.
Okay. All right. So we completed half of this exercise and we were about to start from here. Let's see. Calculate the volumes of the solid objects in the following diagrams. Okay. All right. So now you see we have got the height of this trapezium, and from this particular what can I say, dimensions given, we can also calculate the uh, a surface area as well. So now you could consider it a prism. So let's think that this is a prism, and let's consider this to be the surface area. Okay. All right. So now the surface area would be half times 15 plus 30 times 12. Okay. Now you will get a surface area from here, and then you will multiply with the height, just the height, and then you will get the answer. Okay.
Yes.
The next one, it's uh, it's not particularly not a trapezium. It's looking like it's a rhombus, but let's see. Okay, with the okay, so see this is 65. Okay, so surface area for this would be if we consider rhombus, we need the two diagonals. Okay, we need the two diagonals. Okay, now how can we get them? So how can we get them? All right. So see, this is 65, this is 65, and one second. Let's see. Okay, I have to get the diagonal, right? So if
Yes.
it's 58, um, what wasn't there a particular property for rhombus where we can multiply the yes, not for rhombus. Okay. So see, if we consider it what was the English term for that? Like parallelogram, right? It was parallelogram. So in case of parallelogram,
Yes.
we were using this particular formula where we take the base and then take the height, okay, and multiply that. Okay. Now see, a rhombus has all the properties of a parallelogram, and we in bonus, what it has is the all four sides are same. Understand my point? Like in case of
Yes.
parallelogram, the opposite sides would be like of same size and they would be parallel. Okay, the opposite angles would be same. And these are the properties. Now, in case of rhombus, these are also the properties, but with that, the four sides are same. So we are going to use the property of a parallelogram to get the surface area, which is 65 times 58. And then what is the height? It is 1.25. Okay. All right. Now coming to the next one, we have a cylinder here, right? Okay. I guess. Okay, just a second. So I think we have to calculate this hollow portion, or maybe the portion outside. Whatever it is, this is pretty easy. So for the outer cylinder, we have to calculate pi into 18 square times h is 60. Okay. And for the inner cylinder, it would be pi times 9 square times 60. Okay. Now, I don't understand what they're wanting for us to calculate. If it's the outer cylinder, then this is the answer. If it's the inner cylinder, then this is the answer. If it is the area of this portion, then subtracting these two will give you the answer. Okay. So whichever it is, okay. But there is no like shaded region or something, so it's difficult to. I mean, I hope you've understood the math because that's not difficult. All right. Now see, we have a cylinder and in the top of it, we have a cone. Okay. So in case of the cylinder, what we will have, see this would be the radius of the cylinder as well. So pi times 12 squared times 88. This is the volume of the cylinder. In case of the cone, it will be 1 by 3 into pi into 12 squared times 18. Okay. This is pretty easy things, okay, not like difficult.
Mm.
Calculate the volume of pyramid that is 2.025 meters tall and has a rectangular base, dimensions 1.05 meter. And hence calculate its capacity in liters to 1 decimal place. Okay. So what was the formula in case of pyramids? We calculate the obviously surface area of the base and then multiply it with height and then divide by 3, right? Okay, let me check it. Okay. All right, so see, 1 by 3 times base area times height, okay? So the what will be the base area? The base area would be the area of the rectangle, which is 1.05 multiplied by 0.0745, then multiply with 2.025 and divide by 3.
I
Calculate
have a
the
question.
volume. Yes, go ahead.
How do you find the surface area of a cone?
The surface area of a cone. Okay. The surface area of a cone is pi r squared. Okay. Because in case of cones, this is our like the one surface that we have. Okay. Because on the other side, we only have a vertex or just a single point. Okay. So that won't be our surface. So we will consider this to be the surface, and as it looks like a circular shape, so we calculated by pi r squared. Okay. Similar in case of like cylinders, like pi r squared. And then times it with the height h to get the area. And as we read previously, that in case of like cones or pyramids, we have to divide by 3. And why do we divide by 3? That is not part of our syllabus for now. Okay. So pi r
Mm.
squared would be the surface area. Okay. Understand?
Okay.
All right.
Yes.
All right, so the next one, calculate the volume of a pyramid that has a base area. Okay, you will be able to do that. A rectangular base, yeah, a length, okay. And then a height of 3.6 meter triangular base with one side length of 1. Okay. So, I mean, you will be able to do these, okay? Just like in case of one, base area is given, in case of another rectangular base, and the dimension is given. And in case of another triangular base and their height is given. Okay, so this is how all of these are given. Now let's see, it's a prism. Obviously, you could understand the diagram shows the dimensions for proposed house extension. Calculate the volume of insulation required in the roof. It takes up an eighth of the overall roof space. What? Okay, okay, okay. All right. So first of all, let us calculate what will be the a volume of the roof and then divide by 8 to get the volume of insulation. Okay, but why do we need this actually? What I'm thinking. Okay, let's see. First of all, the area for this would be like the bottom portion. It would be 3.5 times 5 times 8. Okay, that would be the area for the rectangle. Now, in case of the upper portion, it's a like a triangular prism, right? So that would be 5 times 2.5 times half. Okay, that is the area of the triangle or the surface area for the prism, and the height of the prism is 8. Okay, so that would be the, I mean, what can I say, the volume of the triangular prism or the roof. Actually, this is the roof, right? Now, what are they saying? They are saying that the volume of insulation required in the roof, if it takes up 8 of the overall roof space. Okay, the roof is like this portion, right?
Yes.
Right, it's not the whole portion. That is what I'm guessing, because in case of these sorts of houses, these are found countrysides, and they are usually like one-storied buildings, and then this portion seems to be the roof. That is what my guess is. This whole portion cannot be the roof, right? Okay, am I correct?
Yes.
Okay, all right, good. Calculate the volume of a sphere of radius. Okay, correct. For decimal height calculated. Okay, so this is easy. 4 by 3 pi r cubed. Okay, nothing else. Calculate the radius correct to the nearest whole number of a sphere that has a volume. Okay, so 4 by 3 pi r cube would be equal to that, and then just solve the equation. Okay, so 4 by 3 pi r cubed will be equal to 4.187, then multiply both the sides by 3 upon 4 and divide by pi, and then cube root it. Okay, right. Calculate the volume of an object that is composed of a hemisphere of radius 1.5 meter that sits on top. Okay, so we have done some sort of example like that. So already you can see that there is a hyperlink, okay, showing that we have done something like that previously. A wheat farmer needs to purchase a new grain silo and has the choice of 2 silos. Okay, one is cylindrical with a conical top, and the other is cylindrical with a hemispherical top. Use the dimensions shown in the diagrams to determine which silo holds the greatest volume of wheat and by how much. Okay, so there is no need for, okay, actually the cylinder shapes are different. Okay, so what will you do in case of this one? You will have to calculate the volume of the cylinder, which is 6.5 times 5.5, not 5.5 actually, it will be 5.5 upon 2. Okay, so this is the diameter, we need the base. Okay, so squared into, we have already taken h, so this is pi. Okay, so that would be for our cylinder, but also we have this hemisphere, so that would be 4 by 3 divided by 2. Okay, divided by 2 times pi times 5.5 upon 2 cube. Did you understand what I did here?
Yes.
Okay, good. And in case of this one, we will get 4.5 upon 2 squared times pi, okay, times 9.6, okay, and plus, of course, for the cone it would be 1 by 3 into pi times 4.5 upon 2 squared times 1.5. Okay, so you'll calculate the values in the calculator to get which one is greater. The glass pyramid in the courtyard of the Louvre Museum in Paris has a height of 22 meters and a square base with side lengths of 35 meters. Fine. Determine the volume of the glass pyramid. Okay, very easy. Like a square base with the side lengths of 35 meters. That means the surface area would be 35 squared. Then divided by 3 and multiply with 22 to get the volume of the glass pyramid. A second glass pyramid at the Louvre Museum is called the inverted pyramid as it hangs upside down from the ceiling. If its dimensions are one third of the larger glass pyramid, what is its volume in cubic centimeters? Okay, see, that means that height will become 22 upon 3 and the side length will become 35 upon 3. So that means what you will get is the base area would be 35 upon 3 squared, okay, then multiply by 22 upon 3, okay. So that means that it will be reduced to 1 upon 27 of the actual volume, okay. Now you might have asked one question as a previously that as we orient a particular shape, does the volume change? The answer is no. That is why we have done it like the previous. Okay, understand my point?
Yeah.
Tennis balls are spherical with a diameter of 6.7 centimeters. They are sold in packs of 4 in cylindrical canisters whose internal dimensions is 26.65 centimeter long with a diameter that is 5 millimeter greater than that of a ball. So the packed vertically in rectangular boxes. Each box is 27 centimeter high and will fit exactly 8 canisters. Okay. The volume of free space that is in a can. Okay, fine. So, all right. So I think if I try to put it graphically, the thing would look something like this. This is the cylindrical canister they're talking about, and there are 4 tennis balls. Those are fit in here. Okay, right. And
Yes.
a total of 8 of these tennis balls can fit in there. Let's see. Let's identify the values that are given for the tennis ball first. So diameter 6.7. Okay. And in case of, okay, so they are sold in packs of 4 cylindrical canisters for the cylinders. Let us mark it with yellow. Internal dimensions are 25 6.95 centimeter long with a diameter that is 5 millimeter greater than that of the ball. Okay. The canisters are vertically the canisters are packed vertically in rectangular boxes. Wait, what? Canisters are then again packed. Okay. Each box is 27 centimeter high. Okay. Let us complete up until that point. Okay. The volume of free space in a canister containing 4 tennis balls. Okay. Let us calculate that first. Okay.
Okay.
So first of all, so what will be the area volume for 4 spherical tennis balls? Okay. The diameter is 6.7 meters. That means the radius would be 6.7 upon 2. Okay.
Yes.
So 4 by 3 into r cube times pi. Okay. Now how many of these balls are there? I would suggest you take notes of this one. 4 by 3 times r cube times pi. And then 4 of these balls are there. So then you will get a particular value. Okay. Let us actually calculate. So 4 upon 3 times 6.7 by 2 cube times pi times 4. That is 630. 630, almost 630. For simplification, I'm considering 630. Okay. Now for the cylinder, it will be pi times 6.75 because it is 5 millimeter greater than the diameter of the tennis ball divided by 2 squared times 26.95. Okay, so all of the units are calculated in centimeters. Okay, obviously be careful while you are calculating the area and volume that the units are same. So shift pi, okay, then times 6.75 upon 2 squared times 26.95. That is 964.4. 964.4. So if you subtract these two values, you will get, I mean, how much space is left. Okay. The canisters are packed vertically in rectangular boxes. Okay. Rectangular boxes. Okay. Each box is 27 centimeter high and will fit exactly 8 canisters along its length and exactly 4 along its width. Okay. So 4 along its width. Okay, correct. So 8 along the length and 4 along the width. Okay, fine. So now how can we calculate it? Let us say, for instance, imagine this scenario that this is a rectangular box. Obviously rectangular means not rectangular actually, that is a three-dimensional rectangular. Okay, so what they are saying is the cylinders, let us say these are cylinders. Okay, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, 7 and 8 cylinders. I mean, not cylinders. Yes, 8 cylinders. Yes. Okay. So 8 cylinders along the length and along the width, it's 1, 2, 3, and 4. Okay. Now, how would you get the dimensions of these? Right? How would you get the dimensions of this? The answer is you don't have to get the dimension. You don't need to get the dimension of the particular rectangle. Okay, why? Because the the whole of this like rectangular box would be filled with canisters, right? Is it correct? Understand my point?
Yes.
Okay. So now the height is already given. Height is already given, so you don't have to worry about the height. Let us calculate the surface area. Then the height will be given. I mean, calculators as well. So how do we calculate the surface area for a cylinder? How do we calculate the surface area for a cylinder? Okay, so that is for these two sides. Listen very carefully. For these two sides, we will need pi r squared, right? The two
Yes.
sides which are like circular. Understand my point?
Yes.
Now, in case of this shape, it sort of looks like rectangle, but actually it's a curved rectangle, right? It's a curved rectangle. Okay. So in this case, what we do is pi RH. That would be our area. Pi RH. What did I say? Pi RH. So the whole area would be pi r squared plus pi r squared plus pi RH. Okay. And see another thing. Do you are seeing one pi RH from this side, but in the exactly opposite side, do we not have another pi RH?
Oh, true.
Yes. Okay. So there will be another pi RH. So all in all, this area of cylinder would become 2 pi r. Sorry, not 2 pi r actually. I mean pi r in if I take it in common, so it would be R plus H plus H. So that would be pi R into twice R plus twice H. If I take another 2 common, it would become 2 pi R into R plus H. Okay. All right. Now, based on this formula, what you need to do is you need to calculate the surface area of a cylinder. Okay. Not surface area, actually, you could say like, or is it a surface area? Okay. You could call it a surface area, but actually it's not a surface area. It's like the whole area. Okay. Whole of the area. Like in case of a brick, okay, if you consider a brick, the brick surface area would be the area on which it stands on. Okay, the area on which it stands on. Okay, but the brick consists of 6 surfaces. Okay, so all of its area combined will be the total surface area of the brick. Understand my point? So there are 6 surfaces for the brick. All of its area combined together would be the total area for the brick. But what would be the surface area for a brick? You could say that on the particular surface it stands on. All right, so having said all of it, let's get back to the point. So now, what were the values? 2 pi, then R was 6.75 upon 2. 6.75 upon 2, then also times 6.7 upon 2, plus what was the height? The height was 26.95. All right, just a second. Just a second, let me think. Do we need the surface area? No, actually. Okay. All right. One second. So yes, it's actually particularly good that we have got the idea of the surface area for the cylinder. Okay. But see, I misinterpreted the question. All right. So, okay, calculate or like derive this equation. Okay. It will be needed in the next chapter as well. Okay, but see, calculate the volume of free space that is in a rectangular box. Okay. You need to calculate the free space in a rectangular box. All right. So what do you need to do? You need to calculate the area of the rectangle, sorry, volume of the rectangle. Okay. So volume of the rectangle would need to be calculated. Okay, and also the volume of how many canisters have we placed in here? It was said here.
8.
And actually, it said that 8 can be fitted along its length, and 4 can be fitted along its width. Okay.
So 32.
Yes, 32. That is correct. But I'm not even wanting that. Yes, so packed vertically in rectangular boxes. Calculate the volume of space that is in a canister containing 4 tennis balls. Volume of space that is in a rectangular box packed full of canisters. Now, I have one question. I think what they're wanting here is that, I mean, the height is 27 centimeters. Okay. For the, uh, I mean, rectangular box. Okay. For the rectangular box. All right. Now you have to calculate, in case of calculating the volume, what you can do is like, as you said, 4 times 8, that is 32 of the uh, cylinders. Okay, then you take the volume of them, then you should be able to calculate the volume of the rectangular box. Okay, now my question is how many okay, all right, yes, okay, so see, yes, okay, now the dimension for the canisters are 26.95 centimeter height. Okay, 26.95 centimeter is the height. Okay, and what is the height for the um, each box? That is 27 centimeter. Okay, now that would be the only difference in calculating the free spaces. Okay, Because other than that, as you can see, in case of like width, each and every cylinder would be like stuck together. Okay, each and every cylinder would be stuck together. If I try to draw it particularly, it would be like something like this. This is the cylinder one, and then another, okay, then another. It would be packed tightly, okay, along the width and along the length as well. Okay, so there are no void spaces. Okay, there are no void spaces, and the little void spaces in between them, I don't think we have to calculate that. Okay, so the only change I think is the height. Okay, because the height is 27 centimeters here and the height is 26.95 centimeters here. Okay, but other than that, I think everything remains the same. So the dimensions for the rectangular box, let's see how can we calculate it. All right, so now these are packed radiuses will be calculated. It becomes wide. I say it becomes difficult in case of three-dimensional objects when the images are not given. Like, what would be the orientation of the cylinders? What would be the orientation of the canister cylinders? Okay, now I am presuming that the orientation would be like the radiuses. Okay, the radiuses would be taken into account, but that might not be the case while packing. Okay, but say let's for instance, let's say this radius is taken into account. Okay, all right. So now what is the radius? 6.7 75 centimeters rather. So how many radiuses are there in this side? One, two, three, four. Okay, so that would give us 6.75 times 4 times 2. Okay, why 2? To get the diameter. All right, understand my point?
G. Yeah.
So now in this case, 1, 2, 3, 4, 5, 6, 7, 8. Now are these oriented like the diameters? Like this, I mean, say for instance, if it's like in this way, then we will get a different dimension. And if it's in like this way, we will get another dimension. But I think it's in this way. Okay, so let us consider that. So then it would be 6.75 times 8 times 2. Did you get this point, the last point that I said?
Yes.
All right, so we have got the dimension for the surface area for the rectangle, then times it with the height, which is 27. Then timing it with 27 would give you the volume. Okay, and next up, what you have to do is calculate the volume for 8 canisters uh, and sorry, 32 canisters. So multiply the volume of the canister with 32. Okay, then you will get the volume of all the canisters that can fit in here, and then eventually you will be able to calculate the void space. Okay, correct. Is it clear? I
Yeah.
know it's a little difficult. Okay, actually you I would suggest one thing, that you follow these steps and let me know if you are getting this particular value, so which will make it more clear. Okay, if the answer does not match, that means we have some problem in our procedure, so then we will have to do it again. Okay. But I think this should be the way. All right, now coming towards the next chapter, that is, okay, let me give you another link. Do you need to use the washroom?
Uh, Maybe.
Okay, all right. I will give you the link. Join as soon as you get.